This video is for key quadratic transformation parameters. So what we have these parent functions. So x squared is a parent function, and that parabola looks like this. And if you would plug values into x squared, you'd get, if you plugged 1 in, you'd get a 1. If you plugged a 2 in, you would get a 4. And so if you graph these, so I'm going to do it purple so it matches what you're seeing. Hopefully this will show up. And so that's what it looks like when you graph it. And so there's two things that you can have. You can have stretch and compression. So vertical stretch is when you stretch it this way. Vertical compression is when you compress it back this way. And then horizontal stretch is when you make it wider. So you stretch it or you pull, or yeah, it goes this way. And then horizontal compression is when it goes in this way. Hope I told you those two right. So first we're going to do negative 2x squared. So in your calculator, you can put negative 2x squared in. And so when you graph it, you're going to see that it flips upside down because we learned from the last notes that if this is negative, it's a frown. And then it's also, you can tell it's skinnier. It has stretched it, and so the parabola has gotten skinnier. So it's going to be a taller graph. And so what you do is you multiply your y values by -2. And a way that you can graph this and get points is if you go to your table, you can grab points off this table. And they're hard to see there. They show up better on this one. So we had negative 2x squared. So second table. And so here we still have 0, 0. So we're still going to have a point there at 0, 0. And then you can see here that we've got +1 and -2 and -1 and -2. So those 2 points. And then you can go one more. So here I've got -2 and -8 and +2 and -8. So those are 2 more points that you can pull so that you can graph this parabola. And so what it means is that you're multiplying the y values by -2. So for example, up here I had an ordered pair of 2, 4. And so if I multiply the y values by -2, I would get 2, -8, which is one of the points that we had. So then another thing that I can do is vertical compression. So it's not going to be as tall this time. And then horizontal stretch. So I'm going to stretch it out this way. And so I can do that by doing 1/2 x squared. And so you can see here that my parabola is a lot fatter. It's a lot wider. And so I can go to my table and same thing, you can pull points. So here I've got 0, 0 again. So we're going to be back there. I don't like doing half points. So I'm going to use this one here, -2 and +2, +2, +2. So -2, +2, 2, +2. And then I'm going to use this one here, -4 and +8. And then +4, you can see that down here, +4 and +8. And so you're always trying to pick points that'll fit on the graph that you've been given. And so what you're looking for is, with something like this, when you have a -2 in front, when you have a whole number in front, the graph is going to be vertically stretched. And then if you have got a number less than 1 in front of x, the graph is vertically compressed. And so again, this should be a y. All right, so inside this, I've got my parent function graphed again. So now we're going to do vertical translations. So we're going to do x squared plus 3. And what this does is it moves my whole parabola up by 3. So every point, we just added 3 to all the y values. So now, instead of being at 0, 0, I'm at 0, 3. And then I've got negative 1, comma 4, and then positive 1, comma 4. And then negative 2, comma 7, and positive 2, comma 7. And so again, what it means by adding the 3. So again, I've got the point on my purple graph there of 2, comma 4. And so if you know your original points, you're just going to add 3 to that y value, and it would become 2, comma 7. All right, and then the next thing I'm going to do is x squared minus 3. And that's going to shift my entire parabola down 3 units. So I would subtract 3 from all my y values. So here I would have 2, and then 4 minus 3 would be 1. And you'll see that when we look at the points here. So I'm at 0, negative 3 now. So I'm here. And then I'm at negative 1, negative 2, positive 1, negative 2. So here and here. And then I'm at negative 2, positive 1, and 2, positive 1. And you can see that point right here on my graph. And so that's what the vertical translations look like. So if you have added or subtracted something from your x squared or your a value, that's going to shift it up and down. And then our last one is a horizontal translation. So again, the purple is our vertical. And again, just to pull a point for you, 2, comma 4 is one of the points of that purple parabola. And so here what I'm going to do is in parentheses, we're going to do x plus 2 and then square it. So this, we've added or subtracted something after the exponent. Here, we've added or subtracted something before the exponent. And so when you've added something before the exponent, this is going to shift it to the left. And these are always opposite. So if this is a positive 2, this is called an h value. So it's actually the opposite. Your h value would actually be negative 2 because it's this format, at x minus h squared. So to get a plus 2, you would have to do minus a negative 2. So I hope that explains why there. And then here I've got points again. So now I'm at 0. If my x is 0, whoop, right here is where I need to be, sorry. So negative 2, 0, that's my new vertex. So it has shifted it 2 to the left because it was at 0, 0. So if I shift it 2, and then I've got negative 3, positive 1, and then I've got negative 1, positive 1. And so again, we're going to subtract 2 from the x values. So if I subtract 2 from here, I'm going to get 0, comma 4, which would be here. And so 2, comma 4 is this point. 0, comma 4 is this point. So you can see how I've shifted it 2 over. And then I had negative 4, positive 4. And so there's my new green parabola. And so that was this one. And then now what we're going to do in orange. So now we've got x minus 2. So my h value here would be a positive 2. So again, remember that the value of h is the opposite of what is written. So if I graph this one, you can see my parabola has now shifted to the right. So same rules, everything just shifts 2 points to the right. So now my vertex is at 2, 0. And I've got a point at 1, positive 1, and then 3, positive 1, and then 0, 4, and 4, 4. And so for this one, you're adding 2 to all x values. So if I add 2 to this 2, I would get 4, comma 4. and that would be this point here. So you can see that I've shifted 2 points to the right. Okay. So the main things that you need to take away from this are down here at the bottom of this page. So when we're talking about this A value here, if A equals 1, which means there's no value there typically, there's no vertical stretch or compression. If the absolute value of A is greater than 1, it's going to stretch it vertically. If the absolute value of A is in between 0 and 1, so these are your fractions and decimals, that's a vertical compression. And then if A is less than 1, so now we're talking about negative numbers, then this is going to reflect across the x-axis. It's going to flip it either into a frown or into a smile. Now, when we're talking about B, again, if B is 1 or there's no value there, like there wasn't here, there is no horizontal stretch or compression. Now, if the absolute value of B is in between 0 and 1, so again, these are just your fractions, your decimals, you're going to have a horizontal stretch. And if B is greater than 1, or again, absolute value of B, you're going to have horizontal compression. And then C are going to be your horizontal translations. So if nothing is subtracted from the x before it's squared, you're going to not go either direction, left or right. If C is greater than 0, then you're going to translate it right. If C is less than 0, you're going to translate it left. And then finally, D. If you have a number added or subtracted after the exponent, if there's nothing there, there's no vertical translation. You're not moving it up and down at all. If D is greater than 0, you're going to translate it up. If D is less than 0, then you're going to translate it down. So that's it for this video.